Buenos dias. How you doing? Yogi here again. This is the third video in a series of 7 looking at ratios. In my last video, I went through some examples of how to write and simplify ratios in situations involving amounts with different sized units, amounts written in decimals, and amounts written as fractions. The key idea was to end up with a ratio that was made up of whole numbers only. In this video, we are going to look at comparing a pair of amounts in such a way that we can see how much bigger or smaller the first amount is compared to the second amount. To do this successfully, we are going to simplify the original amounts to a ratio where the second number in the ratio is 1, and the first number will usually be a decimal number. This type of ratio is called a unit ratio. Let's see how this works with an example. Let's look at an example of 2 rivers in Australia. We can write the ratio of river lengths in simplest form as 654 is to 59, noticing that we do not write the units in a ratio. The ratio is written correctly, but it does not really give us a feel for their relative sizes. Obviously the Goulburn River is longer, but how much longer? Writing the ratio of their lengths as a unit ratio makes answering this question easier and gives us values that are more meaningful. To write a unit ratio, we want to divide both numbers in the ratio by the second. So we divide 654 by the second number, which is 59, which gives us 11.08, and we divide the second number by itself to give us 1. So now we have a ratio of 11.08 is to 1. This is called a unit ratio. It's not like a normal ratio where we're supposed to use whole numbers. It does have a decimal in it. You can identify it as a unit ratio because the second number in the ratio is 1. What does this unit ratio tell us? The Goulburn River, the first number, is about 11 times longer than the Murrumbidgee River, the second number. This information was not obvious when looking at the original ratio of 654 is to 59. The first number in the ratio is called the scale factor. Notice how the scale factor is a decimal number, not a whole number. Now again, generally we do like to write ratios using a whole number, but in special cases such as using unit ratios, it is necessary to use decimal numbers. Now given a unit ratio, the scale factor can be used to determine the original size of an object. Let's see what this means with another example. In example 2, we want to look at the ratio of the height of an elephant compared to the height of a pony and see that it is 3.14 is to 1. If the elephant's height is 4 meters, what is the height of the pony correct to 1 decimal place? Pause the video here and see if you can work out the answer. There are 2 ways that could be used to work out the answer. The scale factor can be used, or an algebraic method could be used. Let's look at both of these methods one at a time. After you've seen both of them, try and choose one method you prefer. Starting with the scale factor method, we want to write the ratio using words to make sure that the numbers are put in the right order. We know that we are looking at the height of the elephant compared to the height of the pony in that particular order. This tells us, if we look at the words written down, that we should write down the numbers in the order 3.14 is to 1. Now, we can use this unit ratio, and we know it's a unit ratio because it ends in the number 1, to find out our answer using a bit of logic. If the pony is 3.14 times smaller than the size of the elephant, dividing the actual height of the elephant, which is 4 meters, by the scale factor of 3.14 will give us the height of the pony. So we can write down the height of the pony is equal to 4 divided by 3.14, which is equal to 1.27. This tells us that the height of the pony is 1.27 meters. The following 2 bullet points are a little bit tricky to think about, and I'd spend some time looking at them and making sure that you're very clear on what they mean. They explain when to divide by the scale factor and when to multiply by the scale factor. In this particular situation, in this question, we had to divide by the scale factor. Pause for a moment and read through these bullet points. We can work out an answer to the question using another method, an algebraic method. To do this, we start by writing two equivalent ratios. The ratio of the actual elephant height to the actual pony height will be equal to the unit ratio. If we write this down, we can see how the two ratios are equal to each other. We know that the elephant's actual height is 4 meters. What we don't know is the height of the pony. As we do in algebra, when we don't know a certain quantity, we give it a symbol. Let's call the height of the pony, which we are not sure of, P. If we substitute the number 4 and the letter P into our ratio, we will end up with 4 divided by P is equal to the unit ratio 3.14 is to 1. Now we can use some algebra to work out what P is equal to. The first thing is to get the P on top. We don't want to have variables, pronumerals, on the bottom of a fraction. A little trick that we can use is to flip everything upside down. So where we had 4 divided by P, we're going to flip that over so we have P divided by 4. And if we do that to the left-hand side of the equation, we know that we need to do that to the right-hand side of the equation too. So the unit ratio 3.14 is to 1 will be flipped over, so we get 1 is to 3.14. We can now get the P by itself by multiplying both sides by 4. If we multiply both sides by 4, we'll end up with an equation where P is by itself on one side, which is what we want in algebra, and P is equal to 4 times 1 over 3.14, which gives us the same answer as the previous method. P equals 1.27 meters. So the height of the pony is 1.27 meters. Both the methods shown in this video, the scale factor method and the algebraic method, are equally as good as each other. However, in some cases, using the scale factor may be confusing, considering when to divide by the scale factor and when to multiply. I would recommend that you stick with the algebraic method. Let's do one more example to try and understand how to use unit ratios. Let's go back to our pancakes. In a recipe for pancakes, there is 1.6 times as much flour as milk. If we actually use 1.25 cups of milk, how much actual flour is required? Once again, we can work out the answer to this question by using one of two methods. Let's start by looking at the scale factor method. In the scale factor method, let's start by writing the ratio using words to make sure that we have the right order. In the question, it tells us that we are comparing the amount of flour to the amount of milk, and we can write this in words to make it very clear that this is the order that we're looking at. The numbers that go along with this are 1.6 is to 1, so there's 1.6 times as much flour as there is milk. We can use this ratio, which happens to be a unit ratio, to work out how much flour is actually needed. We know that 1.25 cups of milk ends up being used. Imagine we just started with 1 cup of milk. If we wanted to end up using 1.25 cups of milk, we would need to multiply by 1.25. Now we know that if we do that to one side of the ratio, we need to multiply by 1.25 on the other side of the ratio. We can see then that the amount of flour is given by 1.25 times 1.6, which gives us 2 cups of flour. In this situation, we see that we have multiplied by the scale factor. Please consider the 2 bullet points below to make sure that you understand when to multiply by a scale factor, as we have done in this example, and when to divide by a scale factor, as we did in the previous example. We can work out the same answer by using the algebraic method. Again, we start by writing 2 equivalent ratios. the ratio of actual cups of flour used to actual cups of milk used will be equivalent or equal to the unit ratio of 1.6:1. We know that the actual cups of milk used is 1.25 cups. What we don't know is how much flour is used. Again, since we don't know how much flour is used, let's give it a symbol. Let's call it X. Substituting the number 1.25 and the pronumeral x into our original equation, we get x divided by 1.25 will equal the unit ratio 1.6:1. To get x by itself, we multiply both sides by 1.25. This will give us x by itself equaling 1.25 times 1.6 divided by 1, which then works out to be 2. So once again, we find out that the actual cups of flour used is 2 cups, except this time we used an algebraic method. That was pretty heavy duty. Take some time to go over what you've just been shown. We've seen how a ratio can be simplified to make the second number in the ratio equal to 1, and that this kind of ratio is called a unit ratio. Unit ratios can be useful in comparing the relative sizes of two different objects. They can also be used to find the size of one object given the unit ratio and the size of the second object. It's pretty mind-boggling. In the next video, RAT004, we'll have a look at how ratios can be used to find amounts. Until then, take care and adios.